In 2025, space exploration crossed a silent but powerful threshold. There were no headlines about humans landing on Mars just yet, but behind the scenes, the technologies that will take us there were finally being born. This was the year when Mars stopped being a dream and started becoming a destination. What happened in 2025 that made our journey to the Red Planet not just possible, but inevitable? Let's find out. The 21st century space race isn't about flags and footprints anymore. It's a new kind of race, a collaborative marathon fueled by both fierce competition and unprecedented cooperation. In 2025, we saw this in full swing. Private companies like SpaceX, Blue Origin, and a host of smaller, agile startups were no longer just launching satellites. They were building the core infrastructure for deep space travel. Think of it like the California gold rush. It wasn't just the miners who got rich. It was the people who sold the shovels, the wagons, and built the railroads. That's what's happening now. Companies are building reusable rockets, orbital refueling stations, and lunar bases. Not just for glory, but because there's a real sustainable economy taking shape beyond Earth. Government agencies like NASA and the ESA have shifted their roles. They're now the visionaries and the safety regulators, setting ambitious goals like the Artemis Accords and funding the high-risk, high-reward research that private industry can't tackle alone. This public-private partnership is the engine driving us to Mars. It's creating a robust ecosystem where innovation can thrive, costs can drop, and the dream of a multiplanetary species gets a little bit closer every single day. Now, let's talk about the brains of the operation. The journey to Mars is impossibly complex. We're talking about a mission that can last for years, covering hundreds of millions of kilometers. Humans can't manage every single detail, every calculation, every potential emergency in real time. That's where AI comes in. In 2025, artificial intelligence in space wasn't just about autopilots. We're talking about truly cognitive systems. Imagine a spacecraft that can diagnose its own mechanical failures and perform repairs autonomously using robotic arms. Picture rovers on the Martian surface that don't need a joystick operator back on Earth. Instead, they can analyze the terrain, identify scientifically interesting rock formations, and decide on their own where to explore next. This is a huge leap. The communication delay between Earth and Mars can be up to 20 minutes each way. You can't fly a drone in real time. But with advanced AI, our robotic explorers become our true proxies. Our eyes and ears on another world, making discoveries while we sleep. These AIs are also crucial for the human element. They can monitor astronaut health, manage life support systems, and optimize resource consumption down to the last drop of water and the last watt of power. These thinking machines are the unsung heroes making the trip not just possible, but survivable. Getting to Mars is one thing. Getting there efficiently is another. For decades, we've relied on chemical rockets, basically controlled explosions, to push us through space. They're powerful, but incredibly inefficient. It is like trying to cross the ocean on a jet ski. You burn a massive amount of fuel for a relatively short trip. 2025 marked a turning point in propulsion. The big headline was the first long-duration test of a nuclear thermal propulsion engine, or NTP, instead of a chemical reaction. An NTP engine uses a small nuclear reactor to superheat a propellant like liquid hydrogen, shooting it out of a nozzle at incredible speeds. This technology can cut the travel time to Mars from 9 months down to as little as 4 or 5. That's not just a time saver, it's a lifesaver. Less time in space means less exposure to dangerous cosmic radiation, less strain on life support systems, and less psychological stress on the crew. It fundamentally changes the entire mission architecture. Alongside NTP, we also saw huge advances in solar electric propulsion. These are the marathon runners of space. They use massive solar arrays to generate electricity, which then powers ion thrusters that emit a gentle but constant stream of charged particles. They can't get you off the ground, but once you're in space, they can accelerate a spacecraft to incredible speeds over time, sipping fuel with unbelievable efficiency. These are perfect for sending heavy cargo missions to Mars ahead of time. The propulsion revolution of 2025 gave us a choice: the nuclear sprinter for our astronauts, and the electric marathon runner for our supplies. So you've got your fast rocket and your smart computer. How do you keep your astronauts supplied for a years-long mission? You can't pack everything you need. The sheer weight would make the mission impossible. The answer is to live off the land. a concept known as Insight to Resource Utilization, or ISRU. And 2025 was the year ISRU went from a laboratory experiment to a field-tested reality. On the surface of Mars, rovers equipped with new generation instruments were demonstrating this lifeline. The most important of these was MOXIE 2.0. The original MOXIE on the Perseverance rover proved you could pull carbon dioxide from the thin Martian atmosphere and convert it into oxygen. The 2025 version was 100 times more powerful. It wasn't just making enough oxygen for a person to breathe. It was producing it on an industrial scale. Why is that so important? Because rocket fuel is mostly oxidizer. By making oxygen on Mars, you're essentially making the main ingredient for the fuel you need to come home. This single technology breaks the tyranny of the rocket equation, which says you need fuel to lift fuel. Instead of launching a massive tanker from Earth, you can refuel on Mars for the return trip. Other ISRU experiments were drilling for water, ice buried beneath the Martian soil, and testing methods to extract it. Water is life, but it's also a source of breathable oxygen and hydrogen for fuel. These technologies are building a lifeline to Mars, turning a barren planet into a potential oasis. Even with faster ships and local resources, Mars is a hostile environment. The biggest threat to our astronauts isn't a crash landing, it's the invisible danger of space itself. Two things in particular: radiation and microgravity. In 2025, we made breakthroughs in understanding and mitigating both. Deep space is flooded with galactic cosmic rays and solar particles that can shred DNA and significantly increase the risk of cancer. On Earth, our magnetic field and thick atmosphere protect us. In space, you're exposed. Researchers in 2025 were testing new materials for spacecraft hulls, lightweight composites interwoven with hydromachiators that are much better at blocking radiation than traditional aluminum. We also saw the first human-rated tests of active shielding concepts, generating localized magnetic fields around a spacecraft's crew quarters, creating a mini magnetosphere to deflect incoming radiation. Just as important was the fight against the effects of Z. Living without gravity causes muscles to atrophy and bones to lose density at an alarming rate. New centrifuge designs were tested on the space station's small, human-sized pods where astronauts could spend an hour or two each day in simulated gravity, tricking their bodies into thinking they were back on Earth. Advances in biotechnology also allowed for real-time genetic monitoring, identifying the specific biological pathways affected by spaceflight and developing targeted therapies to counteract them. This is the science that will keep our explorers healthy enough to do their jobs and, more importantly, to come home safely. For a long time, our focus has been singular, Earth to Mars. But in 2025, the picture became much more complex and interesting. Mars was no longer the sole destination. It became part of a larger interplanetary network. The key to this was the Moon. With the Artemis program in full swing, humanity established a permanent foothold on the lunar surface and in orbit with the Gateway Station. The Moon became a crucial stepping stone. It is much easier to launch a mission to Mars from lunar orbit than from deep within Earth's gravity. Well, water ice mined from the lunar poles could be converted into rocket fuel at the Gateway, turning it into a true interplanetary gas station. Mars also gained new companions. In 2025, a constellation of next-generation communication and GPS satellites was deployed into Mars orbit. For the first time, future astronauts on the surface would have a bandwidth, internet, and precise location tracking, just like we have on Earth. This orbital infrastructure is a game changer for safety and exploration. It means future missions won't be isolated endeavors. They will be connected to an entire network of assets on the Moon, in Mars orbit, and back on Earth, creating a robust, resilient system that makes deep space exploration safer and more sustainable than ever before. Mars is no longer alone in our plans. It's the anchor of our burgeoning solar system presence. So why was 2025 so important? There were no parades. No one giant leap moments broadcast to the world. But 2025 was the year the foundation was truly laid. It was the year the powerful engines of the public-private space race hit their stride. It was the year our machines started to think for themselves, solving problems millions of miles from home. It was the year we tested the propulsion systems that will turn a 9-month ordeal into a 4-month sprint. It was the year we proved we could live off the land, creating a lifeline of air and fuel from the Martian atmosphere itself. It was the year we developed the science to protect our explorers from the invisible dangers of space. And it was the year Mars became a connected node in a growing interplanetary network. Landing on Mars will be an incredible moment for humanity. But history will show that the journey didn't begin when the first boot hit the red dust. It began in the labs, on the launch pads, and in the silent vacuum of space during these crucial formative years. 2025 was when the path to Mars was paved. The journey is still long, but for the first time, the destination is truly in sight. That will keep our explorers healthy enough to do their jobs and, more importantly, to come home safely. In space, you're exposed. Researchers in 2025 were testing new materials for spacecraft hulls, lightweight composites interwoven with hydromachiators that are much better at blocking radiation than traditional aluminum. We also saw the first human-rated tests of active shielding concepts, generating localized magnetic fields around a spacecraft's crew. Thanks for watching. If you're as excited about our future in space as I am, make sure to subscribe for more deep dives into the technology that will take us to the stars.